So, colligative properties, guys, these are properties that are based on what? We talked a little bit about them yesterday. The what?
Concentration.
Yeah, so guys, they're based on concentration, okay? Basically, the more what in solution, the more, what's that term? Solute. All right, so the more solute you have in your solution, the greater effect that it's going to have on these properties. And we'll talk about what the properties are in just a second. So basically what I have written here, right, is the more things. What do I mean by things? The more particles, right? So guys, particles could be, like somebody said, ions. They could be molecules. All right, those are typically the two that you're going to see. But the more of those you have in solution, the greater the effect they have. So two of the big things, the properties that we'll talk about again in just a second, are melting point and boiling point. And there's a couple others as well. We talked a little bit yesterday about electrolytes, right? What are electrolytes? Okay, Gatorade's an example. That's not telling me what they are.
They are.
Again, that doesn't tell me. Not exactly. What's the definition of an electrolyte? Yeah, they conduct electricity in water. Why? John, now you can answer that. Why? Because they have ions. They've got charges in solution, guys. So electrolytes are better than non-electrolytes, and here's why. They dissolve into more particles. All right? They dissolve into more particles. Really, ions. Okay? And again, electrolytes, right? They conduct electricity because of their charges, and that's the key. They conduct electricity because of their charges. And again, that's why we have ions, because they have a charge when they're in solution. If we were to take a solid electrolyte by itself, like sodium chloride, you hook it up, it's not going to really conduct. But once they dissolve and form their ions in solution, that's how you know. All right, then they have their electricity being charged because of those ions. All right, the electrons and the electricity can then flow because of those positive and negative charges that are present in the solution. So again, the idea that we briefly talked about yesterday was the more ions you have, the greater the effect they're going to have on your properties. All right, so let's talk about colligative properties there. Which is better? So C6H12O6. What is C6H12O6? All right, glucose or NaCl. Which one's going to be better? NaCl. Why NaCl? Because it's what? It's ionic, guys. That's what it is. Ionic compounds are better than molecular ones. So jot that down in your notes if you don't have it. Ionic compounds are better than molecular. Because why? Yeah, they break up, guys. They break up. They do have charges. Okay, that affects the electrolyte properties. All right, but we're just talking about the colligative properties and more particles and solutions because they break up. They break up into ions, which again, that makes them electrolytes, but they break up. Molecules, folks, are going to stay together. So I drew on the board for you yesterday, all right, two beakers. All right, we had glucose in one, so C6H12O6, and we had NaCl in the other one. All right, so let's say we added 4 particles in each. So we had water in our beakers. Okay, and then we added 4 moles of each. Okay, so I'm just going to represent those with 4 different blocks. So we've got glucose, 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 kind of a solid, kind of all together. Well, when they hit the water, they will dissolve and they will spread out. So you've got glucose in each one of these. Okay, but there's only 4. They break up into 4 particles because that's what you had. Sodium chloride, on the other hand, if you had 4, as a clump together, well, they're going to form what? Is it 4? It's going to form 8. Why? Because sodium chloride, guys, breaks down into Na plus and Cl minus. You've got Na plus, Na plus, Na plus, Na plus, and you've got Cl minus, Cl minus, Cl minus, Cl minus. So you have twice as many particles, which in this case, guys, they're ions. You have twice as many particles in solution with sodium chloride because it's split up into the ions. Molecular compounds will not do that because they're molecular. They will stay together. So inside of these circles here, right, it's supposed to be glucose inside there. I just didn't have space, but glucose is in each one of those. That's what those circles represent. So the more particles in solution, the greater the effect it's going to have on these colligative properties. So really the idea that I say or kind of relate to you guys, you get more bang for your buck with ionic compounds than you do molecular because they split into multiple pieces versus just one particle together. Does that make sense? Questions? All right. So the three colligative properties that it affects, like you have in your notes, vapor pressure lowering. All right. So vapor pressure, guys, what is vapor pressure dealing with? Review from Unit 10. It's what? It's forming a what? A gas, right? So this is where you have a substance and it is evaporating to the gas stage, all right? But it's evaporating. It's not being boiled or anything else. It's evaporating. Those particles are just escaping into the gas state of matter, okay? So why would this lower it? Well, inside your beaker, like we had before, it's not just water that you have in there that's escaping to the gas phase. All right, but you also then have, like I said, the Na plus and Cl minus. So they're taking up space. It's not as easy now because of the charges that are there, right, and the dissolvability of whatever substance you had. It's not as easy for particles to escape, the water particles to escape. So it's going to lower the vapor pressure. Meaning if you had a bottle, it's not going to have as much pressure when you open the cap from when it evaporated. Okay, does that make sense? You're going to lower the vapor pressure. Without the particles dissolved in solution, your vapor pressure will be what? It would be higher or lower? Higher, right? It's going to be higher because you don't have those particles taking up space. When you add particles to it, it lowers the amount that are going to escape. Your pressure is lower. Now, freezing point depression. For you guys, we talked about this yesterday. My other classes, we didn't. All right? Freezing point depression. What does that term depression mean? Lower, right? So with freezing point depression, we're going to lower the freezing point. Right? I'm abbreviating that with FP. So like I said yesterday, okay, this is why roads get salted in the wintertime. Right? So when you have water and snow and rain or whatever, precipitation that's melting on the roadways, they put salt on the roads to then when it mixes with the water or the moisture that's on the road, it will lower the freezing point of the water. Right? So the more particles you add, the greater the effect it has. So this is the formula to calculate that. We're not going to do any calculations right now. We probably will come back later in the year and do the calculations for it. But your change in temperature, guys, depends upon how much you have. All right, so K is a constant, but then M is the concentration of particles you have, the molarity, all right, the moles. So the more you add, the lower it's going to take the freezing point. All right, so instead of water freezing at 0 degrees Celsius, when you add particles to it, it may freeze at -2 degrees Celsius. That's a decent amount of temperature change to then keep the roads safer so you can get out there and traffic and, everything doesn't shut down. All right, it doesn't shut down as much. Like I said, back home for me in New York, when they know it's going to be super cold, they won't just use sodium chloride. They'll use something else like magnesium chloride. Why would magnesium chloride be better than sodium chloride? Yeah, look at the particles. So sodium chloride, we said, is going to break up into Na plus and Cl minus. Magnesium chloride would break up into what? Mg2 plus, and then you'd have Cl minus 1 and Cl minus 1. You would have 3 particles here versus 2 with sodium chloride. Again, more bang for your buck with magnesium chloride. Now, why don't they use that all the time? Or why don't they use other salts that have more ions? Why do you think? It's more expensive, exactly, right? It's all about, it comes down to cost efficiency there with that. So when they know it's going to be super cold for a long period of time, they will use the more expensive stuff. But if it's going to be just kind of normal, quote-unquote normal conditions, then they'll use the basic stuff because they have a lot of that back where I'm from. Now, that's freezing point depression. So the more particles you have, the lower it's going to take the freezing point. Now, boiling point's the opposite. Elevation, what does that mean? It's going to increase. It's going to raise the boiling point. Okay? Same principle, though. The more particles you have, the higher it's going to raise it. So the analogy that I gave was, I asked, does anybody put salt in their water when they're cooking pasta? All right, now, you may just put a little bit of salt, and that can add some flavoring, but if you were to put enough salt in there, you can actually raise the boiling point higher. When we talked about pressure and how that changes, if you're cooking at a higher temperature, what will happen? You'll cook what? Faster, right? Your pasta will be done faster, and you get the added benefit of a little bit of extra flavoring. All right? So same thing, guys. It has two effects. You either lower the freezing point, or you raise the boiling point. And in those names, guys, they say it all. Get your reference packets out for a second. You got to know, guys, that depression means to lower and elevation means to raise or increase. All right, that's the big thing you got to remember with that. And again, what does it come down to? The number of particles. So you're going to look and see, okay, if it's ionic or covalent, that's the first thing you're looking at. And if it's ionic, okay, which one is going to have more? Which one's going to have more ions produced? All right? That's it. That's all we're talking about right now with colligative properties, guys. It's concepts. So let me give you just an example here. All right? Let me give you an example. I'm going to go back here. If I had, of these 5 substances, which one is going to have the greatest effect on the colligative properties? Raising the boiling point the most, lowering the freezing point the most, or lowering the vapor pressure? Josh? Why do you say MnCl4? Because it has more particles. Is CO2, are these going to break up right here? No, they're molecular. So how many particles will they have? They're going to have 1 particle each. NaCl is going to have how many? 2 particles. BaCl2 is going to have 3. And then MnCl4 is going to have 5. So that's going to have the most bang for your buck. The most particles dissolved in solution. All right? Those are the types of questions you're going to have. We'll do some practice with it tomorrow with review after our vocab quiz. All right? So again, reminder, vocab quiz tomorrow. And tonight you've got your problem set due by midnight. All right, let's go back here. We're going to talk about something else. We'll come back to the review practice later on. All right. Solubility curves, guys. The last new topic we've got to talk about. All right, so, folks, when we take a look at these solubility curves, you're going to take the notes on one of those that I just passed out. Okay. Excuse me, that'll be your notes. I'm going to kind of talk through it here on my slides. You're going to want to take the notes that I take on the blank one that I just gave you. If you want to fold it over so you see only one curve, that's a good idea. That's fine. You can leave it flat, whatever you want to do. So, guys, solubility. What is solubility? What does that mean? Yeah, dissolvability, guys. It's the ability to dissolve or to break down. So what these curves are showing us is a bunch of different salts. And again, what does salt mean? Ionic. Any ionic compound, okay? So these are showing a lot of different salts. Now, are salts the only things that are up there on this one? No, we also see a few what? Molecular, guys. They're going to be gases. So the first thing on mine, gases it shows with dotted lines, solids are with solid ones. Every solid line, as you increase temperature, what happens to the solubility of your solids? They what? They increase, guys. Every solid line goes up as you go from left to right. However, the gases, now some of the gases I have, you may not have on yours. I think you have them all. All right. The gases there, guys, are what? What's happening to those as you increase temperature? Decreasing. So, one thing you want to jot down is for solids, as temperature goes up, solubility does what? Is that what that shows? Solids go up, right? So for solids, as temperature increases, your solubility increases. For gases, as temperature increases, what happens to the solubility of gases? Solubility decreases. That's something big you want to remember. So the big thing here with solubility curves, guys, these are not super difficult. Okay, they're kind of confusing at first, but once you see it, they're like, oh, this is really not that bad. I will almost guarantee you that you will see one on your final exam, which, by the way, final exams are in only about 2.5 months, like 2 months and a week. All right, they're coming up very, very quickly. And 1 week of that is spring break. Then AP exams will start. So they're coming up. They're right around the corner. So what we're looking at, guys, the hardest part about this is making sure, 1, you're on the right line. So I encourage you guys to always write and use your pencil and draw lines to make sure you're at the right spot. And 2, understanding what the question's asking. So what this graph shows is these are the number of grams here. So all these numbers that are listed over there on the y-axis, guys, that's you're showing your solubility. It's the grams of solute. Okay? So those numbers show you grams of whatever you're putting in with water. Well, how much water do you have here? 100 grams. So don't get those two things confused, guys. This graph here shows the grams of solute, so those numbers that you see on the y-axis, that go in or dissolve in 100 grams of water at that temperature. So, you've got to recognize that those grams there are not water. So in a question, it's going to tell you 100 grams of water or 200 grams of water. You've got to know what to do with that. So really you're going to see how temperature and the number of grams relate to one another. All right, so the 100 grams, again, is because volume will change. So they don't put milliliters up there because your temperature is changing. If you change your temperature, the volume of water will change as well. As it gets hotter, the volume increases. We talked about that earlier on in this unit. So that's why they give you the 100 grams of water, because that's going to be, it's not going to change one bit. So let's just jump into some questions here. So how do we determine it? We're going to figure out the mass of solute needed to make a saturated solution. So before we go any further, let's talk about saturated, unsaturated, and supersaturated. What does that term saturated mean? Full. Okay? Full. Now, in terms of the graph, all right, it doesn't just mean full, or how do you know where it's full? In terms of the graph, guys, that a saturated solution is when you are on the line. Okay, when you're on the line, it's a saturated solution. Another term we have is unsaturated. So saturated means full, unsaturated means what? Not empty, but not full. There's space to go. So where do you think that's going to be in terms of, in reference to the line? It's going to be below the line. All right, it's going to be below the line. And then we have a term that is supersaturated, and that's a unique term. Can't spell that. Supersaturated. What did you say, Gabby? Yeah, guys, supersaturated contains more solute than a saturated solution. Now, in terms of the line here, where do you think supersaturated is going to be? Above the line. Okay, but it's not that simple to get a supersaturated solution. Supersaturated is not where you just keep adding and adding and adding, and then, oh, you've got a bunch left over in the bottom. That's not a supersaturated solution like when you make, anybody make chocolate milk where you have so much syrup. This happens to me all the time, as you guys know. Right? When you add so much syrup that then at the end you have just syrup at the bottom, that is not a supersaturated solution. Okay? That is a saturated solution. It's holding as much syrup in the milk as possible, but then whatever's left over is just there. Guys, a supersaturated solution is where you have to heat it up to get more be able to dissolve. Anybody make their own sweet tea?
Yes.
How do you make it? You what?
Boil it.
You boil it right. Guys, the point of boiling the water is, one, the hotter something is, the faster something is going to dissolve. We can see that here on this curve. As temperature goes up, solubility goes up, so that means it's going to dissolve faster. But two, by heating it up, you can get more sugar in that water when it's hot than when it's colder, room temperature. So you can get more sugar, make it sweeter. Anybody ever have sweet tea where it's so sweet that you start to see crystals of sugar start to form and kind of fall out of solution when it's cold? You've got to stir it up. Anybody have sweet tea like that? I've heard about that. I've never seen it because I don't drink this stuff. But folks, that'll sometimes happen. That's how rock candy is made. You ever make rock candy as a kid? You have to heat it up, you get a lot of sugar, and then you just let it sit. And when it starts to cool down, crystals will start to form, and that's what a supersaturated solution is. All right? In reality, a saturated solution, when you have stuff left over at the bottom, whether it's a salt or whether it's chocolate syrup and chocolate milk, whatever it may be, just because there's stuff at the bottom does not make it supersaturated. Supersaturated is only when you increase the temperature so you can fit more in there than it can normally hold. But in terms of these graphs, a supersaturated solution is where it's above the line here. Unsaturated is below the line, and saturated is on the line. Question? So you'll see in just a second what I mean by on the line, below the line, and above the line. Let's jump into some practice so it makes sense. Me talking about it makes it so much more complicated than what you're actually doing here. Instructions here, guys. Read through it. All right, they're there. It's repeated for each of the temperatures. You're really looking at how temperature is affecting the number of grams. Okay? So here's our example. You're going to look at your graph. I'm going to show one up here in just a second. It says, what substance has a solubility of 90 grams per 100 centimeters cubed, or 100 grams of water at a temperature of 25 degrees Celsius. So here we go. We're going to go to our graph. All right. This is not in your notes, so you're just going to do this and look at it on your note sheet, the solubility curve that I gave you. So we have 90 grams and 25 degrees Celsius, guys. So we're going to go where 95 grams is. All right, that's right about here. And I'm going to go to 25 degrees Celsius. I'm going to go up to where they are, like so. So the question says, what substance has a solubility of 90 grams at 25 degrees Celsius? All right. I kind of went off a little bit. There's some interpretation here. All right. The one that is closest to is going to be which one? Sodium nitrate. And I'll be honest, guys, some of the solubility curves, they're a little bit different. I believe yours is right on the line. Is that true? When you look at yours that I gave you, even though mine isn't showing up that way, all right, there's a little bit of different ones will show a little bit differently, guys. Go with the closest one, okay? And I also went...
You said 95.
I did 95, too. That's the reason why. I was like, why in the world is that going on? It's supposed to be 90. My apologies. So 90, guys, go right over here, right there, on the line. That's what I mean by on the line. Saturated, guys, is on the line of your substance that you're looking for. So if it's saturated, the conditions that you're given will be on the line. If your conditions that you're given are above the line, it would be supersaturated. If they're below the line, it would be unsaturated. Let's take a look at another one. What substance has a solubility of 200 grams? Now, yours only goes up to 150, so you're going to have to look at mine. 200 grams of water with per 100 centimeters cubed of water at a temperature of 90 degrees Celsius. So the same thing. You're going to go back to your graph. 90 degrees Celsius, you go all the way up to 200, which is going to be right about there. So for mine, that would be potassium nitrate. You guys don't have that. So based on the questions you're going to have on a test on Thursday, it'll be based on your graph. Okay? Here is another type of question you could be given. So you can be given both conditions and ask which substance meets those criteria. Or it could be something like this. Bless you. What is the solubility? So they're giving you the substance and they're giving you a temperature. So what is the solubility of potassium nitrate at 80 degrees Celsius? So we're going to find the line for potassium nitrate. That's this one right here that's going all the way up like this. So we're going to 80 degrees Celsius. We're going to go, I can't draw a straight line. It's not that funny, all right? You get the gist, folks. Okay? So what's the solubility? Now we're looking for what? What number? How many grams, folks? So for us, that's about what? 170 grams. All right, that's how we're doing these questions. Again, I realize, folks, that you don't have these particular ones in your notes. I'm showing you some examples of what you can see. So we can also do the opposite. You could be looking for the temperature. So they give you now 95 grams. So we're looking for sodium nitrate. Sodium nitrate is this line right here. Okay, it's that line right there. So 95 grams. You guys, I believe, can do this one on yours. Go ahead and do it. So, 95 grams. Bless you. You're going to go to where it's saturated, has a solubility. So we're going to go over to the line. What temperature is that? 30 degrees Celsius. Folks, these are the types of questions you're going to answer. All right? Either you're looking for a temperature or you're looking for an amount. Now there's one other type, and this is the other type of question that you could see. So it says, what is the solubility of sodium chloride? You guys have sodium chloride in yours. All right, so you're going to take a look at it and try this one on your own. So what is the solubility of sodium chloride at 25 degrees Celsius in 150 grams of water? Do your best to answer this question. So take a couple minutes and solve it on your own. All right, so a couple minutes there, you should have had this done. So what are we going to use to figure this out first, guys? What's our key piece? 25 degrees Celsius. So I'm going to go over where that is. That's right here. I'm going to go up to my line for sodium chloride. And there's a little bit of wiggle room here. What do you guys think that number is? 35, 36, I'm maybe 37 or 38. Now, this is 37. I'm going to say just 37 grams in how much water? No, this is 100 grams of water. So it's asking you for if it was 150, but your graph, guys, shows only 100. So what do we have to do to figure out how much would be in 150? Do a proportion, guys. So we're looking for X grams of solute in 150 grams of water. So you're going to solve a proportion. Now, 150 is a little bit more challenging, but if let's say it was 200, all you would have to do then is what? Double, right? Because you went from 100 to 200, so you're going to do the same effect. 100 to 200 is doubling it, so you would double your amount of solute. Here, we do the math. 37 times 150 equals what? What's that? 5,550. All right, we're going to grams equals X times 100. Divide by 100. Divide by 100. So X equals 55.5 grams, guys, something like that. So a lot of times it's going to be 200 or 300 or it's going to be 50. So you're either going to double it or triple it or cut it in half. That's the other type of problem you're going to see with these solubility curves. You either have to do a little bit of math. You've got to recognize, though, guys, when it says 150 grams of water, that your graph only shows 100 grams of water. That's the key. You have to recognize and know. So with this, when you're estimating, I would not accept 40 for this amount of solute because it doesn't touch the 40 line. I would not accept like 31 or 32 because it's obviously a little bit more than half. All right, so there is some wiggle room, but it's not just unlimited wiggle room here with these questions. Folks, there's one other type of question that you could have. It says, sometimes you'll need to determine how much additional solute needs to be added to an unsaturated solution to make it saturated. So, for example, 30 grams of potassium nitrate has been added to 100 grams of water at that temperature. So here we go. All right, 30 grams of potassium nitrate. So first off, find potassium nitrate. Potassium nitrate is this line right here. Okay? We have added 30 grams already. All right, so that's this line right there at 50 degrees Celsius. So where we're at, guys, is right here. Follow along with me. All right. What type of solution do we have here with that, where that dot is, that blue dot? It's unsaturated because it's well below the line. So the question is saying, how many additional grams of solute will we need to add to make it saturated? So we are trying to figure out this space right here. So there, all the way down to there. We have already added 30 grams, but how much will it take to get it saturated? It's about what? 80, what's the value we need total? 83, 84, something like that? You with me? Right here where that red dot is. So guys, you're going to see what your interpretation is. 83-ish. 84 grams is what this says right here. Okay. So how do we figure out how much is needed? We're going to take our total for that saturation point at that temperature. So it's 84 grams is what is needed. We have how much? Needed. Minus 30 grams we have. We're going to subtract out. How many more do we need? 54 grams more needed to make it saturated. All right? Questions? What I want you guys to do right now in your packet, on page, I believe it's, what page? 12. Go through and you're going to answer those questions on page 12. These are the answers to your solubility curves worksheet. If you have any questions, we can go over them tomorrow when I'm back. So hold on to them. The homework is another solubility curve practice worksheet. You're going to need to use the solubility curves of solids worksheet that the sub passed out to you to answer that homework tonight. It is due tomorrow. Test on Thursday, vocab quiz tomorrow, and that's it.